All right, so we want to talk a bit more about tree diagrams, and we're going to talk about independence as well. So there's some conditional probabilities and things that we can talk about in here, like the idea of a false positive versus a false positive given that I tested positive. So if you look at this table, you can see that some people have the allergy, some people don't. And for people who have the allergy, it's 80% accurate. For people who don't, it's 90% accurate. Okay. A false positive means that someone does not have it, yet they test positive. And so the false positive is 9.9%. Okay. Probability of a false positive. Oh, and by the way, you multiply. This is conditional. Given that you have the allergy, you have an 80% chance. So you can multiply straight down. Given that you have the allergy, there's a 20% chance. So you can multiply down. Okay. Given that you do not have the allergy, there's a 10% accuracy. Given that you do not have the allergy, there's a 90% accuracy. And you can see all these numbers are just the products of their lines or paths on the tree diagram. Okay. And these all add up to 100%. All right. Now, probability of a false positive given that I tested positive. So given that I tested positive means that I need all of the positives on bottom. So who's positive? Oh, well, this guy tested positive. So those people tested positive and these people tested positive. Okay. So given that I tested positive, there is a 10.7% chance of testing positive. So probability of false positive given positive. So 10.7% were the positives. And what's the probability that I got a false positive? 9.9 out of 10.7, which is about a 90% chance, okay, that if you've tested positive, there's a 90% chance that it's a false positive. That's crazy, okay? It's counterintuitive, but it's really because there's such a small proportion of the population that actually has the allergy that all of these yeses don't add up to a large amount. And so if you put all the positives together, you get 10.7% of the population will test positive, but only 0.8 out of that are true positives, and 9.9% of this 10.7% are false positives. So you leave the doctor's office and they say, oh no, you tested positive for this allergen. Guess what? There's a 90% chance that that's a false positive. And so you want to make sure you get second test, okay? Because if you're in this 89.1%, then you're more likely going to get that negative again, okay? So tree diagrams, they help reveal conditional probabilities, but starting to work through these things, you might need to add up things if there's a conditional. Given that something happened, given that I tested positive, you got to add up those, and then the probability of a false positive, okay? Independent events. We've talked a lot about these, but now that we have this concept of a conditional probability, we can define independent events a little bit better, okay? The probability of B given A is the same as the probability of B. What we're saying is A and B are independent if this is the case, because we're saying B has a probability of happening. And if that probability doesn't change, given that A happens, that's the definition of probability. When A occurs, it doesn't change B's probability. If A occurring changes B's probability, then they're associated, okay? If it's not equal, then they are, A and B would be associated. It's the opposite of independence. So, for example, probability of getting an A is 3392 out of 10,000. Probability of A, given that you are a liberal arts major. Out of the liberal arts majors, we see this right here, 2142 out of 6,300. And that comes out to, here, I'll punch it in my calculator right here, because I don't have that one on. 2142 out of 6,300, and we get 0.34. Okay, comes out right on the nose. So these are about the same probability. Okay, how equal is equal? That's where we get a little bit of subjectivity in here. Depends on sample size, really. That might be different if we have a large enough sample size, but these are pretty close. And so you could call these independent because they're basically the same probability. This rounds off to 0.34. This is 0.34, okay? And so the probability of getting an A and an A, given that you're in liberal arts, is about the same. And therefore, liberal arts and A's are independent of each other, okay? If you think back to stacked bar graphs, we would say that these are associated because they look different, right? What we're saying is the probability, so these red bars actually look about the same. So the probability of sedan and probability of sedan given that you're in a particular country might actually be the same. So sedans, it looks like we're going from about 18 to 78. So we'll call that 60%. That's about 60%. That's about 60%. So let's say that that's 0.6 and that's 0.6. Sedan and country, and United States at least, could be independent of each other because knowing that I'm from the USA does not change my probability of it being a sedan. But probability of truck is about 5% here and we'll say 10% here. So that's a total of 15%. But if we divide it up three ways, let's say the probability of truck is about 0.1. But the probability of truck given Europe comes out to 0. So these are independent. These would be associated. Okay? And so independence, the probability of B given A is equal to the probability of B. And if it looks the same, like these red sections are all about the same height from left to right, is a sign of independence. But when they start varying in sizes like these greens, is a sign of an association. All right? So good luck and farewell.